Hello, this is problem number 4 found in your geometry textbook. This is found also in lesson 10.8 on page 670. We're talking here about using an archery, which means we got to find the area. It says an archery target is 5 colored zones that formed by concentric circles. That just means one circle inside of another, and so on. The target's diameter is 122 centimeters. Of course, that means the radius would be 61, or half of that. The radius of the yellow zone is 12.2 centimeters. So from here, the radius of that, which is just half of it there, from here to here, would only be 12.2. The width of each of the other zones is also 12.2, so there would be 12.2 there, and 12.2 there, and 12.2 there, and so on as you go out. If an arrow hits the target at a random point, what's the probability that it hits the red zone? Now, in order to find the red zone, you're really going to have to take the radius of 12.2 plus another 12.2, that's where this is coming from, or a total of a radius of 24.4. And then the yellow circle has a radius of course, 12.2, which is the smaller one. So what you're going to have to do, and of course the radius of the whole circle itself is the 122 up here divided by 2, or 61. The reason we do that is because we're dealing with circles, we need to deal with, of course, pi r squared, because that is the area of a circle. So you can see here that it's pi r squared. This represents the red circle, minus, because the red is not completely in that whole circle, it is the red circle minus the area of the yellow circle, which you have to take out of that, because it's like the big circle, but all this is not filled in. You've got to take away the yellow from it. So that's why they're doing pi r squared, or pi 24.4 squared minus pi times 12 squared. And then, of course, you're dividing that, if you're going to find probability, over the area of the whole circle, which is pi times 61 squared. And then mathematically, you can load these into your calculator, and when you get done, you should get 0.12, which is approximately 12%. All right. So now, as we look, what is the probability that an arrow will hit the yellow zone? Well, if it's hitting the yellow zone is the smallest one, so we don't have to subtract here. It's this whole area right here. So it's simply just going to be pi times 12.2 squared, and then we're going to divide that by pi times 61 squared. Okay, and when you do, you end up with something like 144 pi over 3,721 pi. The pi's cancel, so 144 over 3,728. Your calculator first is going to give you 0.3869, something like that, which is about 3.8% if you move your decimal 2 places to the right. Now, the reasoning says if an arrow hits the target at a random point, is it more likely to hit the black zone or the red zone? So is it more likely to hit here, or this little band that goes right around here in the red zone? Now, we figured out the red zone already, which is right here, and it was the pi times 24 squared minus 12 squared. So we kind of know how to find the area of the red zone divided by well, we could just find the area of the red zone. So because that's what it wants to know, is it more likely to hit the black zone or the red zone? So we've already done the red, so there's no sense redoing that. But if you want to find the area of the black zone, it's going to be pi times, and again, if you go out 12.2, another 12.2, another 12.2, another 12.2, then that ends up being 12.2 times 4 sections. So times 4, and that ends up being 48.8, and you're going to square that. But you've got to subtract out everything else that's inside here, which would be pi times 36.6, because again, it only went out 3 spaces. So you're subtracting the blue, the red, and the yellow area, which is represented by this, and this is the area of the black if the black were completely filled in. So when you find the difference here, of course use your calculator. It's going to be 48.8 squared times pi minus 36.6 squared times pi, and you end up with approximately 3,273.16. And if we did the one that was already here, that one came out to be roughly about 1,357.11 or something like that. So you can see that this has a much bigger area than this one does. It may not appear even in the picture, but this one has a much bigger area. So the arrow is more likely to hit the black one, because this represents the black one. The area most likely is going to look like the black one, or land in the black one, much more than it is in the red one. And all that together, that's what geometric probability is really all about. Best of luck.